Let me write here, look at here. We have two technology, Ethernet and then MPLS. Ethernet is a technology. We use this technology for communicating between the systems in a LAN. You will learn about Ethernet in this course in future videos. But about the MPLS, this is a WAN technology, and this technology should be learned in the service provider, okay, courses, not in this course. But we have another technology, Ethernet over MPLS. Ethernet over MPLS means we are implementing Ethernet over the WAN links, because the Ethernet is a technology of the LAN. Here we are using Ethernet, for example. Let me write here. In the networks, we are using Ethernet. You will learn about it in this course, don't worry. But we don't use the Ethernet normally in the WAN. But with new type of technologies, we call them EoMPLS, or in some cases, maybe you see this term, ELAN, okay? We can connect different LANs to each other with the Ethernet. Normally, in the old days, we used only the Ethernet in the LAN, okay? But now, with newer technology, we can connect the for example, LANs to each other with Ethernet. This means that we are using Ethernet in the WAN. Normally, Ethernet should be used in the LAN, but now we can use Ethernet over the MPLS for connecting the LAN sites to each other. This means that Ethernet now is using for WAN also. But don't worry about the detail, okay? If your service provider can provide the EoMPLS services to you, you can connect your sites to each other with this technology. This is only a name for us. The detail is not important. But now we know that Ethernet is a technology of LAN, and point-to-point is a technology of WAN, and also EoMPLS is a technology of WAN. Okay, this is not relevant to the IP address subnetting. Until now, we learn about the technologies of LAN and WAN, and also a little more than before about the interconnecting the networks. Here we have three networks, network A, network B, and network C. These three networks are residing in different areas. Because of that, we need to use the service provider. We need to give help from the service providers or telecommunication companies to connecting our networks to each other with different technologies. Maybe in one area, your service provider, your telecommunication company can give you only EoMPLS, not point-to-point. Or in some areas, maybe your service provider can give you point-to-point or not EoMPLS. Because of that, this is variable because the service providers, you are using different technologies. Okay, you will learn about it, don't worry. Now let me to talk about the IP addressing subnetting from operational view. The question is that if this is your company, okay, how you can assign addresses or design addresses to this, for example, network from operational view. Here, we don't want only assign IP addressing or design IP addressing. We need to design or assign IP addressing or subnetting for this network operationally, and because of that, you need to see the conditions that you have in your network. Okay, for example, you know that in LANs means local area networks. In almost in all cases, we have many computers, many PCs. Assume that in these three LAN, okay, we have 200 PCs, and also in the for example, in the network B, also we have 220 PCs. And also in the network C, let me write here, in network C, we have 165 PCs. Okay, and your task is the designing of the IP addressing or subnetting for this company. One simple work that we can do is that, for example, we can use this range. Let me to write here. Okay, let me first remove this information from here. Very good. Look at here. This is my design. Oh, this is only for example, a simple design. 192.168.10/24 for this network. You know that in this range we have 254 usable IP address. You know it. Okay, and also for here I'm going to use 192.168.20/24. It's okay. And for this network, I'm going to use 192.168.30/24. And also, you know that here we have one link. I'm going to use 192.168.40/24. And for these networks, I'm going to use 192.168.50/24. Okay, this is okay, but this is not efficient. Why? Look at here, between the router 1 and router 2, we have only two interface, the interface of router 1 and the interface of router 2. This is a point-to-point links. Here we don't have, and we will not have any other IP address. But as you can see, 192.168.40 has many IP addresses. For example, starting from 192.168.41 to, okay, 192.168.42. After that, again to 192.168.4.253 and 192.168.4.254. Here we have 254 usable IP address, but we need only two IP addresses here. Because of that, if you use /24 for these networks, you wasted more than 252 IP address, because you only need two IP address, but you use a subnet with 254 IP address. Because of that, this is not a sufficient method. Also for these networks, the link between router 1 and router 3, it's better to using another subnet for example, this link. You know that in the previous scenario we learned that for the links for the networks with only two hosts IP address requirement, we can use /30. Why? Look at here. For example, assume that I'm using 192.168.40/13. This means that we have only 2 bits for hosts, okay? And this is equal to 192.168.4. Then you know that this is the host bits, first subnet bits, 6 S bits, and then 2 host bits, okay, because this is /30, and /30 means we have only 2 host bits. Now, if you want, you can use these 2 host bits for the usable IP addresses that you need. For example, HH can be 00, 01, 10, 11, and you know that we can't use the 00 because this is the network address, and also we can't use the 11 because this is the network address, but we can use these 2 IP addresses, 01 and 10. Let me write here. Look at here, 192.168, okay, 192.168.4. For the first status of 6S, we can use, for example, 60, then 01, and after that 192.168.4, again 60, after that 10. Okay, the next condition, this condition and this condition. This means that now we are using 192.168, for example, 40/30 for this link, okay. Let me to write here, and we have 2 usable IP address, 192.168. Let me to calculate it, 192.168.4.1/30.